Okay, so let's go ahead and talk about the last piece of spatial analysis technique that I want to talk in this particular video, and that's erase. And you can largely think of erase as the opposite of clip, right? If clip was to making sugar cookies, like pushing the cookie cutter in and then taking the cookie out, erase would be if you kept what was left over after you removed the cookie, right? So to say that a little bit more succinctly, with erase, right, what erase is going to do is erase is going to remove the geometry of the erase feature right from the geometry of the input feature. Right. It's going to remove the geometry of the erase feature from the geometry of the input feature. Right. And so if we were to go kind of draw two shapes like we did before, right, our input feature and our, in this case, right, our erase feature, and we were to run erase on this, what we would get as a result would be, right, the exterior of the input feature, right, with a hole in it. Looks kind of like a donut, right? So what clip would have done is clip would have given us back just this interior piece. What erase does is erase removes the interior piece, right? There's now a hole here. Okay, so let that sink in for a second. Erase removes the geometry of the erase feature from the geometry of the input feature. So let's look at a little bit better drawn example here, right? So we have, again, just like before, this green here is our input feature. Right, and this purple here is our erase feature. Right, when we run erase, right, what we get back, what we get out, right, is the input feature minus the areas where they were overlapped by the erase feature, right? Again, these are both holes. Right? So again, erase removes geometry, clip clips geometry. So if we were to given the exact same two inputs that we looked at with clip, right, but instead we wanted to run erase, right, what would the result of erase look like? Right, pause the video for just a second, think this through. I know it's not technically a review question, but I encourage you to just kind of think it through about what would happen if we ran erase and what that would mean. So with erase, what happens, right? Again, this is the, actually let me clarify here. Right, this is our input feature. Right, and this is our erase feature. Right, and if we were to run erase, what would happen is we would take the geometry of the input feature, right, and anywhere that it was overlapped by clip, by the erase feature, right, we would cut that out of the input feature. So we would cut along it like this. Right. And so what we would get back, or the result of erase, would be the parts of the input feature that are not overlapped by the erase feature. Right. And so sort of drawn more elegantly, right, it would look something like this. Right. This is all of the parts that were not overlapped by the erase feature. So let's go through some review questions. But before we do that, I want to make one sort of quick note about clip and erase. And that's that clip and erase, right, do not modify the attribute table. Now, it may modify the number of features in the attribute table, but it's not going to modify the attribute, the columns. Right? It's not going to add or subtract columns from the attribute table. Just keep that in mind. Now, to sort of recap just briefly before we move on to the review questions, right? What we've talked about is we've talked about clip, which, right, clips or subsets the geometry to match the clip features. Right, and then erase, right, removes the geometry, right, of the erase feature from the input feature. Okay, so with those two definitions and a little bit of a review, let's go ahead and dig into some of the questions. So, given these two features here, right, again, green is our input and purple is our, in this case, erase feature, right? What would the result be of an erase operation? Right, so if we have these two inputs, what would the result be of an erase operation? Okay, hopefully you took a second to think about it, and what you came up with was that because we're doing an erase, right, anything that is overlapped is removed from the input, meaning what we would get back would be something that looks like that. Right, and if we look at that sort of drawn to scale, this is what we would end up with. Okay. So let's do a slightly more complicated example. And let's say that we have two features in the input features and two features in the erase features. What would happen if we were to run an erase between these features, right? And again, the green here are our inputs. And the purple here are our clip or erase. So what would happen if we were to run an erase on these features. Okay, well, just like before, right? With erase, we remove any geometry that is overlapping. So we would retain the vast majority of this, right? It would come up, it would come around this tip of the arrow here. And it would do something kind of like that. And then here, right, we would cut around the butt of this arrow here. We would keep going. And then it would cut around the head of this arrow here. Right, and so the end result would be the two inputs minus the parts where the arrowheads overlap. And if we were to look at that, sort of drawn more to scale, it would look something like this. Okay, so let's go through one more question here. Oop. Gave away the answer there. But let's take the same inputs from question 2. So we have the two sort of wavy pieces here and the two arrows for the in this case clip features. Right, so we're dealing with a clip. But given the exact same two input features, right, and the exact same two, in this case they would be the clip features, what would happen if we were to run the analysis using clip? Okay, hopefully you took a second and you realized that with clip, what we do is we keep only the parts that are overlapped. So for this top feature here, right, we would keep this part here. Down here, right, we would keep this part here. And we would keep the head of the arrow here. Right, so we would keep 1, 2, 3 pieces of the input features. Drawn more correctly, it would look something like that. Okay, so let's look at the last question here, which would be given these two input features, input feature, and a clip feature. Right, what would happen if we ran a clip given this arrangement here? Pause the video, really kind of think about it. It's different than what we've seen before. What do you think would happen if we ran a clip? Okay, so hopefully this is going to make logical sense. But right, we have to remember, right, what happens to clip is that we only keep the parts of the input that overlap the clip feature. Right, so in this instance, right, none of the geometry overlaps the clip feature. So we actually get rid of it all. Meaning, right, the end result of this is actually nothing, right? It's actually nothing. There's nothing here because we had nothing overlapped. Okay, so let me repeat that. Right, go back a slide here. Right, the reason why this input feature is removed is because there is nothing overlapping the clip feature. So there's nothing for the clip feature to clip. So it just returns an empty data set or a null data set. So hopefully that all made sense. The idea that we can have the buffer, the different ways that we can modify the buffer to address different things and different issues. And the idea of clip subsetting to a clipped feature, and erase removing the erased feature. And as always, if you have any questions, please reach out. Thank you.